Hello students, welcome to my channel. In this session, we will discuss a previous CAT question based on the concept of binomial expansion. Here comes the question. What is the number of distinct terms in the expansion of x plus y plus z whole power 100? Options are 5151, 5050, 4950, 5149. Students, if you write a plus b whole power n expansion, when we apply the binomial theorem, we write like this: nc0 a power n into b power 0, nc1 into a power n minus 1 into b power 1, plus nc2 into a power n minus 2 into b square. What we observe here, we start with a power n and power of a will be coming down, n minus 1, n minus 2 and so on. Power of b, we start from b power 0. Power of the second term, b, we start with b power 0 and power of b is increasing 0, 1, 2 and so on. So what will be the last term in this expansion? Ncn into a power 0 into b power n. So we started with nc0, nc1 and so on till ncn means how many terms we have? We have n plus 1 terms. So a plus b whole power n will have how many terms in its expansion means we'll say n plus 1 terms. You can see otherwise. You take a power n. You started with a power n up to a power 0 means 0 to n, is it not n plus 1 terms? Or you take b power 0, b power 1, b square up to b power n. So you 0 to n means it is n plus 1 terms. So there are n plus 1 terms in a plus b whole power n expansion. Coming to our question here now, x plus y plus z whole power 100 if I consider, we'll write x plus y as one term. So we can take x plus y as a single term for some time and z as the second term. Right, whole power 100. Now we'll use this a plus b whole power n expansion. It is in the place of n I have 100. So 100 c 0. In the place of a I have x plus y. So x plus y whole power 100 into z power 0. Next 100 c 1 into x plus y whole power 99 into z power 1. 100 c 2 into x plus y whole power 98 into z square and so on. What will be the last term? It will be 100 c 100 into x plus y whole power 0 into z power 100. Now 100 c 0 is 1, z power 0 is also 1, but this x plus y whole power 100, again if you try to expand it using this formula, this particular term again will have how many terms in it? When you're writing x plus y whole power 100, you will get, when you write a plus b whole power n, you have got n plus 1 terms. So when this x plus y whole power 100, when you expand, you will get 101 terms. How this is? Because you have to expand x plus y whole power 100, I'll get 101 terms. We are only writing number of terms. Similarly, 100c1 is 100 into z, 100z, okay. 100z into this I have to do, but this will have how many terms? X plus y whole power 99 will have 100 terms. X plus y whole power 99 will have 100 terms. All those 100 terms will be multiplied by 100z, but number of terms will remain 100. I may have 1, 2, 3 and so on. I have 100 terms. All of them will be multiplied by the whatever is 100z. So number of terms will be same, 100z into first term, 100z into second term, 100z into third term. Number of terms, I am not asking what is the value, I am asking how many terms will be there. X plus y whole power 99, when you expand, there will be 100 terms. Similarly, x plus y whole power 98, when you expand, it will be n plus 1, that is 99 terms and so on. If you look at last one, 100 is 1, x plus y whole power 0 is 1, z power 100 means z power 100. So 1 into 1 into z power 100, it is z power 100 means there is only one term or not here? Yes. So now how many distinct terms are there means, this first term again when I expand, it is 101 terms. Second term when you expand, 100 terms, 99 terms and all that. So is it not sum of first 101 terms? What is sum of first 101 terms? You know sigma n formula. Sum of first n natural numbers, n into n plus 1 by 2. If I apply that formula, you have to find sum of first 101 terms means 101 into 102 by 2. You can see 251s. 51 is my answer. So that is choice A, right? So x plus y plus z whole power 100 will have 5151 distinct terms in its expansion, right? Thank you.